We need to know how to find a geometric mean to do the section over similar right triangles. So to start, we're just going to talk about what a geometric mean is. A geometric mean is found when you are given two numbers and you set them into a proportion where it's one of the numbers over an unknown and then the same unknown over the other number. And then you'll cross multiply and solve for x. And then x is the geometric mean. So the geometric mean between 6 and 15 is to put 6 over x, x over 15. And then we're going to cross multiply and solve. 6 times 15 is 90. X times x is x squared. So you're going to square root both sides. Square root of 90, 9 and 10. 9 is 3 and 3. 10 is 2 and 5. Pair of threes, lonely 2, lonely 5. So the geometric mean is going to be 3 square root of 10. So that's the geometric mean between 6 and 15. So for this section, first of all, the first theorem in this section, and don't memorize these numbers, these actually go with the old book numbers anyways. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if you have a big right triangle and you drop in the altitude from the right angle to the hypotenuse, it creates two triangles inside of that that are similar to the original and similar to each other. So you can kind of draw them separated and then you can name the similar sets. So here they have the three similar sets of triangles from there. I'm going to drop to the bottom and then come back to the rules. At the bottom, we're using that particular rule. We've got this large right triangle. We've dropped in the altitude from the right angle to the hypotenuse here, and they even sketched them for us. When you sketch them, it's great if you can make them face the same direction so that the naming will be easier for you. So you can see that the small triangle, they've sort of turned it so that the right angle J is in this corner. The medium triangle, they didn't have to turn at all. And then the right triangle, they sort of had to flip the right angle towards the bottom. So now they're all oriented the same direction and you can name them accordingly. So I'm going to say FJG for the small one there. And then GJH for the medium one. And then FGH for the large one. So that's just naming them. When you're given this picture, you could name three similar triangles. Here are two rules that we're going to need to use. This first one is the geometric mean altitude theorem. And it says if you have a right triangle, altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the lengths of the two segments. So if you have these two pieces, then you can find this piece here using the geometric mean of those two parts. And so they have that set up here. I like to call this one the heartbeat because if I drew out the path of my proportion, it would look like a heartbeat from Heartbeat Monitor. So that's kind of my nickname for it. So it's like number over x, x over number, and then you solve. And of course the x, they could put the x on any part of this, so how you set it up just depends on the picture. The geometric mean leg theorem is using a geometric mean when you don't know the leg. And so it's set up with the pieces of it's the whole hypotenuse and a portion of it as well. So like this first one is A to B, and then CB, which is the leg, and then CB over DB, which is this part that is closest to that leg. And then it can go the other direction as well. AB over AC, and then AC over AD, using this piece that's closest to that side. And so we like to call this one the boomerang. It kind of makes the shape of a boomerang when you draw it out. So like that'd be like, and I usually do the short one first, like DB over BC, CB over BA. And then you can go the other direction as well, using like DA, AC, CA, and then AB. And you'll get the same answer, even though my proportions that I had said were a little bit different than the ones they had here. So we're going to see some samples because I know right now these are not making total sense. I don't know how to spell boomerang either, probably spelled that wrong. But anyhow, let's see some samples of these. So you have to get used to looking at the picture and noticing which of the two theorems that you're going to need to use. In this first theorem, notice that nothing is on this piece here, the altitude to the hypotenuse here. Nothing is on that. So we're not using the heartbeat. We can see that we've got A, and then 6, and then 6, and then 12 is the whole thing. So we can set that up for our proportion. So A over 6 equals 6 over 12, using that boomerang theorem. So that means 12A will equal to 36, and then A will be 3. So that's a pretty easy one right there. The next one beside it, we do have the pieces of the hypotenuse here, and we're looking for the middle section here, so we are going to use that heartbeat theorem, the geometric mean altitude theorem, so 6 over x equals x over 8, where this is the geometric mean of those two numbers. Cross multiplying, we find that 48 equals x squared, and we're going to square root that. And then we're going to do simplest radical forms, so that's like 4 and 12, 2 and 2, 3 and 4, 2 and 2. All right, pair of 2s will only 3. So x ends up being, we got 2 pairs of 2s, so that's 4 out front, lonely 3 inside. So x ends up being 4 root 3. Here is another one, and on this one, I'm noticing, again, I'm not using this piece there, so I am going to do the boomerang going this direction. So it's kind of like that, right? It's got B and 10, and then 10, and then 24. It's the geometric mean leg theorem, so the leg is the one that gets repeated. On the diagonal, it's repeated. It times itself. And 24 there, so I'll have 24 times B. 10 times 10 is 100. Divide by 24. And then you get, if you want to go fraction form, well, 100 divided by 24 gives you 4.16 repeating if you have, and it's just the 6 that repeats there, not the 1, if you want to get a decimal answer. Or if you wanted to get a reduced fraction, you get 25 over 6. And that just depends on how we, if we ask you to round, and if we don't ask you to round, we usually do like reduced fraction form. Number 7, I can see that I'm using this middle piece here, so I am going to do that heartbeat, having 8 over w plus 9 equals w plus 9 over 18. And so this time when I cross multiply, I'm going to have to FOIL those together. 8 times 18 is 144. And so on the right side, we've got w plus 9 times w plus 9. So as I FOIL this together, I'm going to get w squared plus 9w plus 9w plus 81. On the left side, I had 144. At this point, when you have w squared and w, you should know that you're going to have to factor to solve. I'm just going to combine my like terms there first. There we go. And when you know that you have to factor to solve, you want to bring everything to the same side before you factor, and then you'll factor it out. So I'm going to subtract 144 so that I have 0 on the left. And then 81 minus 144 is negative 63. So now I have to factor to solve, and I have to think of factors of negative 63 that will combine to 18. And so being a negative 63, we want different signs, so 21 and a negative 3. If we multiply them, we get a negative 63. If we add them, we get an 18. So we're factoring it to be w plus 21 and w minus 3. And so as you're solving this, w plus 21 will equal 0, which means that w could be a negative 21, or w minus 3 equals 0, which would mean that w could equal 3. So there's two answers, negative 21 and 3. Of course, if I plugged in a negative 21, I'd get a negative value for this altitude. So the negative answer doesn't make sense in this situation. And we only want to keep the W equals 3.